Greetings to everyone. I am Chinmay Vinay Dandavati. Currently, I am pursuing my MSc in Statistics. I am in the second semester of this program, and I am pursuing my degree from the Institute of Science Nagpur, which is an autonomous college under the government of Maharashtra. The topic which I have selected for designing a seminar for this paper of testing of hypothesis is likelihood ratio tests. Before I actually start with my topic, or I actually jump to the topic, I would like to say a few words which would describe my intentions and my idea behind making this seminar. A very few initial points being a recall value of the video which I had made 5 months back titled Fisher's Information and Fisher's Information Matrices. I would also like to show the thumbnail of this video in order to give a recap or to give a recall value. So here is this video on the Fisher's information and information matrices which I had made 5 months back. So in case you haven't watched this video yet, so I would strongly suggest you to watch this video. I have also posted the link to this video in the description section of this current video. And in fact, I would suggest you to explore my channel and to watch almost all the videos. But as regards this presentation on likelihood ratio test is concerned, I would strongly suggest you to watch the video on the Fisher's information first and then come to this present video. So in this video, to explain the concept of Fisher's information and information matrix, I started with the difference between probability and likelihood and slowly extended from these roots of likelihood to the concept of Fisher's information and information matrix. This time there would be another branch from the concept of likelihood going towards the likelihood ratio tests. So in order to summarize the roots or to briefly discuss the fundamental of this likelihood ratio test, I would include a slide from the previous presentation which summarizes the difference between probability and likelihood. Now, on the basis of this root, we come to our actual topic. What is likelihood ratio test? Likelihood ratio test is a very useful framework to make certain statistical tests and to also make decisions statistically. So in order to get an answer to this question, what is likelihood ratio test? I would like to motivate this answer with the help of an example, a real life, real world example, which is pretty easy to connect to and is also in a layman language. So let's say you are lost. You are lost and you don't know if you are in US or Africa. You don't have any technological aid like a global positioning system or GPS. You can't talk with anyone since you don't know their language, neither they know your language. So there is an absolute communication gap. Now, somewhere or the else, there is only these five senses with you, not even five, four, because you can't make any sense of what you listen. So there are only four senses with the help of which you have to decide where you are. Somewhere or the else, you are pretty sure that you are in US, so you believe that unless proven otherwise. So this belief is considered as the null hypothesis. We are in US. Now there needs to be a hypothesis which is complementary to the null hypothesis, which is called as the alternative hypothesis, denoted as H1, which says that we are in Africa. We believe the null hypothesis unless we get the evidences otherwise. But somehow, devising these two hypotheses is not sufficient. We need to take some decision, and for the same to be done, for the decision to be taken, we need to gain some information and we decide to take the information by looking if the temperature is high or low. Since we have only our senses, so we can feel whether the temperature around us is high or low, and we devise this test criteria as if the temperature is low, we are in US, if the temperature is high, we are in Africa. Now, after having decided this test criteria, we need to know some information or to know some general digits. So they are as follows. The information in front of us says that 90% of the places in the United States are cold and 10% of the places in United States are warm. That is in terms of probability. A place in US, the probability of a place in US to be cold is 0.9, whereas the probability of any place in US to be warm is 0.1. Whereas in Africa, 50% of places in Africa are of high temperature and remaining 50% of the places are of low temperature. That is in terms of probability. The probability of any place to be of high temperature in Africa is 0.5, whereas the probability of any place to be of low temperature in Africa is also 0.5. So with this data or with this information, we can always present this information in terms of ratio. We can calculate the ratio of the probability to have high temperature in US to the probability to have high temperature in Africa, which can be calculated as 0.1 upon 0.5, which is as good as 1 by 5. You can also see that I have encircled the relevant part of the graph here, and from this ratio we can get that it is only 1 by 5 as likely to have high temperature in US compared to Africa. Analogously, the probability to have low temperature in US upon the probability to have low temperature in Africa, that is the ratio of the probability of low temperature in US to the probability of low temperature in Africa, is zero point 0.9 by zero point 0.5, which is 1.8. Here too I have encircled the relevant part of the graph, and thus it can be concluded that it is only 1.8 times more likely to have low temperature in US compared to Africa. Now we have this null hypothesis that we are in US. We can get information, or we can get the crux of the data in three forms. The first one being the very commonly found form, in the form of language. The temperature is very high. We can get the same information in form of digit, that 0 area has low temperature. And the final form, or the final way in which we can get the information, is in the form of this ratio, that the ratio of the probability of high temperature in US to the probability of high temperature in Africa is 1 by 5. Somehow all of these statements lead us towards the same output or the same decision, that is to reject the null hypothesis and to accept the alternative hypothesis, that is we are in Africa. In another case, the crux of the data can again be expressed in three different forms. First one being in the form of language, that the temperature is low. Second one in the form of a statistic, which is a representative of sample, that one area has low temperature, it is in the form of digit or number essentially. And the third form is in the form of this likelihood ratio, that the probability of low temperature in US upon the probability of low temperature in Africa is 1.8. And these three statements again lead us towards the same decision, which is to accept the null hypothesis. Now these ratios which lead us towards this decision whether to accept or to reject the null hypothesis are the likelihood ratios, and the tests which are designed keeping in mind these ratios are termed as the likelihood ratio tests. Now we have this null hypothesis that we are in US. We accept the null hypothesis when the likelihood ratio is 1.8. we accept the alternative hypothesis when the likelihood ratio is 0.2. Likelihood ratio, denoted by this symbol, can be defined as the ratio of the observed outcome in US upon the probability of observed outcome in Africa. And now, after defining this likelihood ratio as the ratio of these two probabilities, we have to decide how the cutoff can be decided for the likelihood ratio to accept or reject the null hypothesis. So as per the theory, if this likelihood ratio is greater than or equal to 1, we accept the null hypothesis, and in case it is less than 1, we reject the null hypothesis, or alternatively, we accept the alternative hypothesis. This can be also expressed by using this number line, where we have this red region. For any value to be less than 1, we reject H0, and for any value which is equal to or greater than 1, we accept the H0. So after having dealt with this vast background, now we are in a position to formally define what we have learned so far as a likelihood, what a likelihood ratio test is, which will also be followed by a brief expression. So here is the standard definition of likelihood ratio test. So likelihood ratio test is a statistical test used to compare the fit of two different models, one of which is a special case of the other. Now here I would emphasize on this part of this sentence where it states that the two models are such that one is a special case of the other. Now, in the context of the likelihood ratio test, one model is a special case of the other means that the two models are nested. But again, we need to realize what does it mean for two models to be nested. So two models are said to be nested if one model can be obtained from the other by imposing certain constraints or restrictions on the parameters of that model. And the likelihood ratio test can of course be used to compare these two models and determine whether the data provides the sufficient evidence to reject the null hypothesis, which is somewhere related to the model M0, in the favor of the alternative hypothesis, which somewhere or the else supports the model M1. Now, here we have this mathematical equation which has certain denotations in the beginning. So we have L0 as the maximum likelihood value for the null model which is denoted by the M0, and L1 is the maximum likelihood value of the alternative model which is denoted by M1. Now the likelihood ratio test lambda is calculated as lambda equals to L0 upon L1. This ratio represents the relative likelihood of the data under the null model compared to the alternative model. Now, in case the data which is given to us is a data which follows some well-known distribution, the likelihood ratio test statistic is often transferred into a chi-square statistic by performing certain mathematical treatment upon it. That is, firstly to take log of that likelihood ratio test statistic lambda, and to further multiply it by -2 to obtain the chi-square statistic. Now here we also need to know what is the reason behind doing this -2 times log of lambda. So the reason for multiplying by -2 is that the log likelihood ratio is asymptotically distributed as a chi-square distribution with the degrees of freedom equal to the difference in the number of parameters between the two models. The -2 multiplier is used to ensure that the transformed statistic has the correct chi-square distribution. Now this chi-square statistic follows the chi-square distribution, as I have said, with the degrees of freedom equal to the difference in the number of parameters between the two models M0 and M1. Now, after having dealt with this formal definition as well as this brief mathematical equation, we come to a stage where we can successfully apply the knowledge which we have gained so far into an illustrative problem. So the illustrative problem here is in front of us. So the statement of the problem says that a bag contains 4 red balls and 6 green balls. 2 balls are drawn at random without replacement. We assume that the null hypothesis is that the balls are drawn from a bag with an equal number of red and green balls. The alternative hypothesis is that the balls are drawn from the bag with 4 red and 6 green balls. If the two balls drawn are both green, use the likelihood ratio test to determine whether the null hypothesis should be accepted or rejected. So here is this data which is in front of us, and it is in terms of the language which we use in our day-to-day communication. The first prong of problem solving, or the first fold of problem solving, is to translate this data into mathematical terms which are in the form of symbols, digits, and units if necessary. So we do it. We firstly define formally the null and the alternative hypothesis. So null hypothesis H0 states that the balls are drawn from a bag with an equal number of red and green balls, whereas the alternative hypothesis H1, it says that the balls are drawn from the bag with 4 red and 6 green balls. Now we calculate the probability to draw 2 green balls under the null hypothesis, which is denoted as the probability to draw 2 green balls given H0, which is 5 by 10 into 4 by 9, which is nothing but 2 by 9. We further calculate the probability to draw 2 green balls under the alternative hypothesis, which is given as probability to draw 2 green balls given H1, which is 6 by 10 into 5 by 9, which can be simplified to get 1 by 3. Now we calculate the likelihood ratio as the probability to obtain 2 green balls given H0 upon the probability to get 2 green balls given H1. We substitute, or we plug the necessary values to obtain 2 by 9 upon 1 by 3. We simplify this fraction to get the fraction 2 by 3, which if solved gives the answer as 0.6 recurring, which can be rounded up as 0.66667. So now after solving this data which we have translated from our real life language, we need to retranslate this solution back into the language in which that problem was asked to us. So that is, we need to make certain decision. So since this likelihood ratio is less than 1, we have learned it in the theory that we have to reject the null hypothesis in case the likelihood ratio is less than 1. So here too we reject the null hypothesis. So we have sufficient evidence to conclude that the balls are drawn from the bag with 4 red and 6 green balls. Now I would always suggest to solve the problems by more than one method, out of which the first method is necessarily manual, but there should be a relevance or some dignity to solving this problem by using the uh, technological methods or by using the programming languages. So here I am solving the same problem by using R software. So I am sharing the screenshot of the same problem solved on R. So here you can see I have defined the probability under the null hypothesis as prob underscore null, which is equal to 5 by 10 multiplied by 4 by 9, and I have mentioned what it means exactly. So I have started with a hashtag. So please note that when we start a comment with hashtag, the stuff which we write after it becomes irrelevant from the perspective of the output which we are going to get. That is, anything which we write after the hashtag becomes inert. So we define the probability to draw 2 green balls under the H0. Similarly, we define the probability to draw 2 green balls under H1 as prob underscore alt, which is equal to 6 by 10 into 5 by 9. After having defined these two probabilities, we define the likelihood ratio as prob underscore null upon prob underscore alt, and we also put again a comment to show what it actually means. So it is the process of calculating the likelihood ratio. And as soon as we press the enter button, we get this output which is in blue color. So it is 0.666667, which is the same we got after performing this calculation manually. And now we even make the software to take the decision given these conditions, that if likelihood ratio test is less than 1, we reject the null hypothesis, else we accept the null hypothesis. So the software takes the decision to reject the null hypothesis, which is the same as the one we took after manually solving the problem. So this solves the problem, and this problem which dealt with application of this likelihood ratio test in a real life situation, somehow this was a miniature example, but this nudges us to know how these likelihood ratio tests can be applicable to some real life larger situations and to some larger disciplines and even other branches of science. So here I am listing few of its applicabilities in the real life domains. So the first one being the environmental monitoring. So this likelihood ratio tests, they can be instrumental in the environmental monitoring and can be used to monitor and detect the changes in the environmental conditions. They can also be helpful to uh, the people related to the financial risk management. For example, a bank can use the likelihood ratio test to evaluate the creditworthiness of the loan applicants provided his or her behavior while the loan was given to him or her the last time. It can be even used in the genomic analysis. In the genomics, the likelihood ratio test is used to identify the genetic variants associated with the diseases. It can be used in the medical diagnosis as well. In the medicine, the likelihood ratio test is used to diagnose the diseases based on the symptoms and the test results. And also it can be used in the newly arising field of the image recognition, where we typically have a set of images, each representing a different class or object, and we have to develop a model which can accurately classify new unseen images into one of these previously defined classes. So having discussed this, now I am at the last stage of this seminar. So it's the time for acknowledgements. So here is the list of all the resources which I used to gather the content for my seminar. It is a very vast body of content which I have gone through in order to design my seminar and to gather the content for my seminar. So I thank you for all your precious time and your attention. Thank you. Thank you very much.